Hello, this is Mr. Stansbury. I'm going to take you through the notes on simple discrete data. At the end of this, you should be able to say, I can organize and display discrete data. Okay, so first thing, frequency is the number of occurrences of a particular data value. Okay, so like value 7, 8, 9, and 10, there were 3 7s that were in there. There was 4 8s, 8 9s, and 5 10s. That's the frequency. Relative frequency is the frequency divided by the total number of values, which basically gives you a percent of the data. So if we add these numbers all up, we get 20. And this frequency is 3. So that's 3 of the 20. So that's 0.15, or 15% of the data was a 7. 20% of the data was 8. 40% of the data is a 9. And 25% of the data was 10. Okay, and you should always be able to add up the relative frequency to equal 1, which is 100%. Okay. We could display this information in a column graph. So here we've got 7, 8, 9, and 10. So we go 7, 8, 9, and 10. And then this would be the frequency up the y-axis here. And so there's 3. So at 3, we would make a top bar and fill in a column there. This is 4. This has got 8. And then this looks like it's about in there at 5. Okay. Mode is the most frequently occurring value in the data set. So it's the one with the highest frequency. So that would be 9 this way, or you could look at the tallest bar chart, and that would be 9 as well. Okay. Describing the distribution of a data set. There's 3 different types of distributions here. There's symmetric about the mode, so that means it's like if you cut this thing right in half, it's pretty much like, well, actually cut it right at the mode, the one that happens most often. There should be about this mirror image, a reflection about the mode number. Okay, and then positively skewed and negatively skewed. So the positive side gets stretched out. So normally it goes up like this and then comes back down. So this positive side, this data is getting stretched out this way. So that's why instead of it being all clumped up here in a big bell like this, it actually gets stretched out. So this graph's going to end up going a little bit farther out that way. And there's also the negative side is stretched. So there's negative. The negative side has got kind of the stretched out group of data, and then it's a more clumped here. Up here at the top. So the negative side is stretched out. All right. There's one other thing that we need to know about, and that's outliers. Data values that are much bigger or much smaller than the rest of the values. So if here's all of our data here, and then we got this little piece of data way away from the rest of it, this would be considered an outlier. Okay. So let's take a look at an example that deals with this. All right, before we hit this last example, let's take a little comedy break.
That's the best one I've ever seen.
That one's funny. Sorry. So here we go. Example 4, 20 squirrels. Just so happens we hit some squirrel videos. 20 squirrels enter the 33rd Annual National Squirrel Diving Championships. The first round scores are as follows, all of these here. Record this information in a frequency table. Okay, so that's that table that we had right at the beginning of the notes. So let's create one of those. Okay, so here's our table. Went through and found all the scores, wrote them in there, and then we'll do the frequency. So I would suggest best way to make sure that you get everything is if you actually have this like on a test, you can actually go through and just start crossing numbers off. So we have 1, 6. I don't think there's any other ones. So let's go through. I think 13 was the next lowest score. 13. If we cross them off as we go, then we know we shouldn't miss any. Now 14. So we got 1, 2, 3, 4 14s. 15, we got 1, 2, 3, 4, 5 of those. And then we also have, this is really the tally, and then I'll just write the frequency next to it. 16, we got 1, 2, 3, 4 of those. 17, we have 1, 2, of those. And then 18, we have 3 of those. And the nice part about crossing them all off is that at the end you can tell that you got every single one, right? So the frequency for this is 1, this is 1, this is 4, 5, 4, 2, and 3. Okay, so if we add those all up, that gives us 6, 10, 15, 20. So there's a total of 20 scores in the, because there's 20 squirrels, so I guess that's another way to check. So then the cumulative frequency would be 1 out of 20. So that would be, let's just do this. No, let's do the decimal. It's probably better that way. 0.05. This is 1 out of 20. 0.05. 4 out of 20, which is 0.20. 5 out of 20. 0.25. 4 out of 20. 0.20, 2 out of 20, 0.10, and then 3 out of 20, which is 0.15. Okay, and then if you add these all up, we should get 1.00. That shows that we have all 100% accounted for. Okay, so we have recorded this information on a frequency table. Make a column graph of the data. Okay, so let's do that as well. Okay, so here's our frequency, here's our score. You want to make sure that you label your axes always on your table. Okay, or the column graph. Okay, and you usually want to give it a title as well. So this would be what squirrel scores, squirrel diving scores. Okay, so now we can go through and get our frequencies all figured out here. So let's see, there was 1 at 6, so we can make ourselves a little chart here at 6. And then we've got, the next one isn't until 13, and we got 1 of those as well. Okay, I'm just going to make all the top bars and we'll fill all the rest in. We've got 1 at... No, sorry, we got 4 at 14, so that would be this one here. So that's about here. We got 5 at 15. And then we've got, let's see, 2 at 16. No, 4 at 16. I don't know what's wrong with me. 4 at 16, 2 at 17, and 3 at 18. Okay. Okay, so here they all are filled in. Okay, so we have made our column graph. What is the modal score? So that's one that happens most often. You can look at here, find the highest one, or also look here. Either way, we're going to end up getting 15 would be the modal score. Is there a shape of the distribution? Well, if we ditch this outlier here, yes, 6 is an outlier. If we ditch that, then we have this here, and it's not really got a fantastic shape one way or the other. Is there a shape of the distribution? I would go probably with no, not really. Not really. Okay, yeah, I will stick with that. And then what percent scored above a 16? So above a 16 would mean 17 or 18. So that would be 5 out of the 20 total, which would give us the 0.25 or 25% scored above 16. Okay, if it was above and including, then we would add this 4 and there would be 9 out of 20, but it just says above a 16. Okay, all right, that's all there is for simple discrete data. If you have any questions at all, please feel free to ask. Thanks.